Hello, I am Rajiv Agarwal, science enthusiast and CEO of EduDime. In this lecture, we are going to talk about things that matter. In particular, we are going to talk about the different states of matter. So, matter is anything that has mass and has volume. So, anything that surrounds us that we can see, all of that is matter. In fact, we are also made of matter. I just want you to think for a moment and can you figure out something that you see but cannot be considered as matter? Let's come back to this a little later. Matter is made up of particles, atoms, and molecules that contain thermal energy. This thermal energy gives the particles the ability to move, have velocity, and show different types of dance movements. These dance movements in science are called degrees of freedom. The higher the thermal energy, the greater will be the excitement and the degrees of freedom will be more. So there are five states of matter, right? You are more acquainted to seeing solids, liquids, and gases all around you. But when you increase the temperature of the gases to by thousands of degrees, you get something called a state of plasma. The sun is made of plasma. Plasmas are seen when lightning occurs. It is there in our televisions as well, right? So if you go to very high temperature, then you get plasmas. And if you go to very low temperatures, near 0 Kelvin, you get something called BE condensates, Bose-Einstein condensates. So as you can see that the pressure and temperature, external factors, they influence the interaction between the particles of matter, the forces of attraction and repulsion. And essentially, it is these forces which determine what the state of matter is going to be. Now, let us look at matter at the atomic level. If you look at solids, you see that the atoms are basically vibrating about a given point. These are the most well behaved state of atoms in any matter. Their energy is actually very low. But when you come to liquids, you find that the motion has become more vigorous. The atoms can actually slide past one another, and therefore these are knottier than solid particles. Now, when you come to gases, they have very high kinetic energy, and therefore they can move with very high velocity, and the distance between them is also very high. So they are actually much, much more knottier than liquids. And when you heat the gases, they basically ionize and form ions, positive and negatively charged ions, and they move very, very fast. Now, going to the exact opposite of the plasma is the Bose-Einstein condensate. That means if you lower the temperature to near 0 Kelvin, you see what happens is that the atoms which were there, you see this wide area here, they all start coming close together like what happens in condensation and they start forming one atom. This is what the Bose-Einstein condensation of rubidium 87, an alkali metal. You all know that we can change from one state of matter to the other. So if you increase temperature, then you can go from Bose-Einstein condensate and convert it into a solid. Through the process of melting, you convert a solid into a liquid. Through the process of vaporization, you convert a liquid into a gas. And when you heat the gas even more, a process of ionization makes the gas atoms and molecules break into ions and you get something called plasma, right? This is what plasma looks like. Just the reverse process of this will cause deionization, converting the plasma into gas. Condensation makes the gas into a liquid. Freezing makes the liquid into a solid. And the solid on near 0 Kelvin becomes a Bose-Einstein condensate. Now, if you compare the different states of matter based on thermal energy and temperature, you basically will go from extremely low thermal energy and temperature and you will move progressively towards very high thermal energy and very high temperature. Similarly, the motion of particles in case of BC is absolutely negligible. They vibrate very slowly as you just now saw. And from there, they go to a movement which is faster than we can see in case of plasma. Similarly, in particle spacing, there is absolutely no spacing left in case of BEC, which is more of a clump of atoms together. The spacing is very low in case of solids, it's medium in case of liquids, very high in case of plasma, and high in case of gases. For definite shape and volume, we are still doing research on BEC, so we can't really say what it is like here. But in case of solids, they have both a definite shape and volume. For liquids, as you know, they take the shape of the container, but they have a fixed volume. For gases and plasma, they neither have a fixed shape nor a fixed volume. In case of particle packing, this behaves like a single atom, so it's like very, very dense. Solids are dense and they have a definite pattern of arrangement of atoms. Liquids are not organized, whereas in case of gases and plasma, they are highly random. Coming back to that question, something that we can see but is not an example of matter is fire. All right, so what happens is when you heat a gas by many thousand degrees, the individual atoms collide with so much energy that they knock electrons out, and this is the process of ionization. And only when a sizable number of atoms become ionized, then the gas is called as a plasma. In case of fire, while it is hot, it does not ionize enough particles to be considered as a traditional state of plasma, and for that matter. Therefore, fire is considered more as a chemical reaction and not as a state of matter. BECs, as the name suggests, was this theory was developed by physicist Satyendranath Bose and Albert Einstein in the early 1920s. Now, they did not have equipment at that time which could lower temperatures to nearly 0 Kelvin and create Bose-Einstein condensate, which nearly 75 years later was done by these three scientists, for which they won the Nobel Prize in Physics in the year 2001. So you must be curious, right? That are there more states of matter than the five that we just discussed? Yes, I've just listed them here. And is this the end of the list? I'm afraid not. Just like Alice in Wonderland peeping down the rabbit hole found that the rabbit hole goes deeper and deeper, we have not even talked about dark matter, which is estimated to comprise 83% of the mass of matter in the universe. And as science and technology progresses, we will keep discovering newer states of matter. Okay? So it's time for a joke now. I hope you've heard of Higgs boson, or rather the God particle, which was discovered a few years back uh, at an experiment called the Large Hadron Collider at CERN in Switzerland. Now, this particle essentially gives mass to all the elementary particles that have mass, such as protons and electrons. So the joke goes like this: a Higgs boson goes to a church, and the priest there tells the Higgs boson, "We don't allow bosons here." The boson says, "Without me, how can you have mass?" You get the double meaning there? I hope you enjoyed this video. And for more such videos, quizzes, and discussion, do visit this website. I would love to hear from you. So do send me emails. And till we meet next time, thank you.